Yes. Question number 13. We were doing 13.2. Two balls are drawn at random with replacement from a box. The box is containing 10 black balls and 8 red balls. Okay. And this we have to take out with replacement. Means once the ball will be taken out, it will be kept again for the second chance. Okay. So find the probability that both are red. Probability when both balls are red. Means first we will find the red ball. So out of 8 red balls, we can take out 8. Total possible cases are 8 and total is 18. Okay. And again, we will keep that ball in the box, and again it will become 8 red balls out of 18. So without, it is with replacement, so we are keeping it back. So this will become 2 4 the 8, 2 9 the 18. So 4 4 the 16 upon 9 9 the 81. Now second probability is first ball is black. First ball is black and second is red. Second is red. So first we will find out of the black balls, how many black balls are there? 10. So 10 out of total possible cases 18. Into now second time we have to take the red ball. So second time red ball, how many red balls are there? 8. And the previous one is kept again, so it will become again 18. So 8 by 18. So 2 5 is 10, 2 9 is 18, 2 4 is 8, 2 9 is 18, 5 4 is 20 upon 81. Now probability of one is black and other is red. Now there are two possibilities for getting one. One is black and other is red. So one is black, other is red. They didn't say first is black, second is red. If they have confined first black, second red, then there will be only one case. Here there are two possible cases. First can be red, first black, second red, and first red, second black, or that is plus. So therefore we can say first, in short, we can write the first ball is black, first black. If we are getting first black and second red, or it can be, or means plus, it can be first red and second black and second black. So first red. So first red means out of red balls, one ball is selected, 8 red balls, 8 upon 18. First black, no, black is 10. So we will write first 10 because black we have taken first. So 10 black out of 18, and then 8 red out of 18. Or first is red, so 8, there are 8 red balls, so out of 8 we will select 1, and then black, there are 10 black balls, so 10 upon 18. So you cancel it, you will get 40 upon 81, or you can solve it. 2 5s are 10, 2 9s are 18, 2 4s are 8, 2 9s are 18, 2 4s are 8, 2 9s are 18, 2 4s are 8, 2 9s are 18. So that will be same 20 upon 81 plus 20 upon 81, that is 40 upon 81. So this is with replacement, conditional probability with replacement. Probability, question number 14, probability of solving a specific problem independently. Means probability of solving this problem is PA is equal to 1 by 2. And probability of solving problem B, problem solving by B, probability of solving specific problem by A is 1 by 2, and the same problem solved by student B 1 by 3. Both try to solve problem independently. That means these are the independent events. First of all, these are the independent events, and the problem is solved. Exactly one of them solve the problem. So problem is solved. So in this case, we need the problem, probability of solving the problem, and probability of not solving the problem also find out. So 1 minus 1 by 2 by A, and probability of not solving the problem by B is equal to 1 minus 1 by 3, that is 2 by 3. Okay. So now first question is find the probability that the problem is solved. Probability that the problem is solved. This will be equal to, problem is solved means 1 minus, this is the opposite of 1 minus the probability. None of them solve the problem. Probability of none of them solve the problem. None of them solve the problem means 1 minus probability neither solved by A, that is not A, and nor by B. And these are independent events as it is given in the question. So we can say this will be equal to probability of A dash into probability of B dash. So 1 minus probability of A dash and B dash. A dash is 1 by 2 and 2 by 3. That is 1 by 3. So 1 minus 1 by 3, that is equal to 2 by 3. The problem is solved. Second, exactly one of them solves the problem. Probability of exactly means if first will solve, either first will solve, second will not solve, or second will solve, first will not solve. One of them must solve. One of them solves the problem. Okay. So that means if A will solve the problem, if A will solve the problem, then B will not solve the problem because one of them will solve. Only one. If A will solve, B will not solve. Or if A will not solve the problem, then B will solve the problem. One of them will solve. Okay. This will be the possible cases. So A solved by A is 1 by 2 and not solved by B is 2 by 3. plus probability not solved by A 1 by 2, and probability of the problem solved by B is 1 by 3. So 2 by 6 plus 1 by 6, that is equal to 3 by 6. 3 1 is 3, 3 2 is 6, 1 by 2, 50% chances. If you can't convert, you can multiply by 100. One card is drawn at random from a well shuffled pack of 52 cards. You know that there are 52 cards in a stack of playing cards. So in which of the following cases are the events independent? Okay. So first we start with question number 1, part number 1. So E is the event that the card drawn is a spade card. Card drawn is a spade card. So spade, how many spade cards are there? So probability of spade card, probability of spade, drawing a spade card is equal to your E, you can denote by E and F. So there are 13 spade cards. So 13 by 52. Then probability of drawing an ace. So how many ace are there? Probability of drawing an ace. There are 4 ace. So 4 by 52. Now what is the common between spade and ace? Spade and ace intersection only if there is one spade, ace, spade. So common card is only one. So therefore the probability of spade intersection ace is equal to 1 by 52. Now we have to check whether they are dependent or independent. So independent events, we have to check P spade into P ace should be equal to intersection. So P E or F, you can say this E and this is F. So spade, check probability of spade into probability of ace is equal to 13 by 52 into 4 by 52. So that 4 13 the 52, and 13 and 13 will cancel, 1 by 52, and which is equal to the probability of spade intersection ace, or E and F. You can use E and F also here. Spade for spade E and F for ace. So therefore we got the condition, hence E and F are independent events in this case. Independent events. Then second condition, if E is a black card, probability of black card, and F is the probability of getting a king. So how many black cards are there? 26, and 26 upon 52 probability of E, and probability of F king. How many kings are there? 4. There are 4 kings out of 52 cards. And what about their common cards? So black kings, how many black kings are there? 2 black kings. So therefore the intersection will be 2. So probability of E intersection F will be equal to 2 by 52. Now check for the independency. Now the probability of E into probability of F is equal to 26 upon 52 into 4 by 52. So 26 2 is a 52, 4 13 is a 52. So 1 by 26. And this is also 2 ones are 2. 226 is a 52, 1 by 26. So therefore, we got probability of, this is F, sorry, probability of E into probability of F is equal to the probability of their intersection. Therefore, E and F are independent events. Last, the card is a king or queen. E, king or queen. So king or queen means there are 4 kings and 4 queens. So number of favorable cases to this event will be 8. Okay. The probability of king or queen will be equal to 8 upon 52. Then probability of jack, queen and jack. So queen and jack F. F is the probability of getting queen or jack. So how many queens? There are 4 queens and 4 jacks. So again, this is also 8. So NF is also 8. So probability of getting queen or jack is also 8 upon 52. Now, how many are common? So queen is common. Queen is also here. Queen is also here. So there are 4 common cards between E and F. So number of common cards between E and F is 4. So therefore, the probability of E intersection F is equal to 4 by 52. Now check the whether they are dependent or independent. So probability of E into probability of F, whether they are independent or not. So probability of E is 8 by 52 and F is also 8 by 52. 4 to the 8, 4 13 the 52. So 2 to the 4 upon 169. That is not equal to 4 1 the 4, 4 13 the 52, 1 by 13. So therefore probability of event E into probability of event F is not equal to probability of E intersection F. Not equal to. Therefore E and F are not independent. In this question, in a hostel, 60% of the students read Hindi newspaper. So that means probability of Hindi newspaper is 60% means 60 upon 100. 60 upon 100. That is 0 0 cancel, 3 by 2 3 is 6, 2 5 is 10, 3 by 5. Probability of 40% read English newspaper. The probability of reading English newspaper is 20%, that is 40%, sorry, 40%, that is 40 upon 100, 2 by 5. %20 read both Hindi and English newspaper. So means common probability of Hindi intersection English is 20%. That means 20 upon 100. That is 1 by 5. Question number 1. Find the probability that he or she reads neither Hindi nor English. Probability of H dash intersection E dash, neither Hindi and nor English. So as I told you, from De Morgan's law, we can write probability of Hindi union English complement, and that will be equal to 1 minus probability of Hindi or English. And Hindi or English we have not given. Now we can find out. Either you can stop here number 1 and then you can find here probability. What will be the probability of Hindi or English will be equal to probability of Hindi, or you can put here formula directly. 1 minus this will be equal to probability of Hindi plus probability of, no need of this, probability of English, and intersection we know minus, we know probability of Hindi intersection English. So substituting the value, probability of Hindi newspaper is 3 by 5. English newspaper is 2 by 5. And both is 1 by 5. So 3 plus 2, 5 minus 1, 4 by 5. And because of this minus, 3 plus 2, 5 minus 1, 4 by 5. 5 minus 4, 1 by 5. That is 20% if you want to convert into percentage. Now second, this is A part. In B part, find the probability she reads newspaper already. Then probability of reading the English paper. Means Hindi is already done. Probability of finding the reading of English newspaper when Hindi is already read by her. This is the case. And this you know that this is the conditional probability, and probability of E intersection H Hindi intersection English divided by probability of Hindi. This is the formula that we studied. So one intersection is 1 by 5. 1 by 5 divided by probability of reading Hindi is 3 by 5. So 5 cancel, 1 by 3 is the answer in B case, and C case is the opposite of this. Probability of Hindi newspaper when English newspaper is already read by her. So that will be the probability of Hindi intersection English or English intersection Hindi is the same thing. The probability divided by probability of English. So intersection is 1 by 5 divided by Hindi is 2 by, English is 2 by 5. So 5 cancel, 1 by 2 is the correct answer. Probability of obtaining an even prime number. So how many even prime numbers in a die? So only there is one even prime number. You know that even prime number is, what is even prime number? Yes, Tabrez. Even prime number is Which one is even prime number? There is only one even prime number in the world, that is 2. This is even as well as prime. So in a die, how many die on each die when a pair of die is rolled? Pair of die is rolled. So that means 6 is the 36. Possible cases are 36. And on each die, 2 each die. And so that means 2, 2 is the favorable cases. Only 2 and 2 will be the favorable cases. 1 and total number of cases, 2 dice are thrown. So therefore 6 into 6, 36. So it should be 1 by 36. The answer is D. Yes, two events A and B will be independent if A and B are mutually exclusive. No, it will not compulsory that if they are mutually exclusive, then they are equal, not necessary, and not necessary. It is also wrong always. Cannot be equal to this. Only this is possible because if A and B are independent events, then A intersection B, this is intersection missing. A intersection B, A intersection B should be equal to probability of A complement into probability of B complement, not A, not B, or it can be written as 1 minus probability of happening an event PA, 1 minus PA into 1 minus probability of B. So the answer is B.